forward with these committee meetings. We have 2 other ADWR staff online helping us in the operation of this webinar. You've heard Zach Richards. He'll be the primary operator. He's going to be muting and unmuting you. He's going to be reading your questions and your comments in the chat box. When he unmutes you to speak, he will let you know when you are unmuted so that you can go ahead and speak and not before you're unmuted, because we wouldn't want to miss anything. Also, because we may be getting very proficient in webinars, but maybe WebEx, the platform that ADWR currently uses, is not real familiar to everybody like Zoom has become. So in a couple of minutes, Zach is going to give us a quick spin around the screen tutorial on all the different features and functions that you can use through this meeting. We don't want any barriers in your way to keep you from participating. Also online, ADWR staff is Teresa Johnson. She is the one to chat if you are having audio difficulties or any kind of technical difficulties. In your chat box, you can do a private message to her, and she can help you work through those problems. I will be operating the slides, and Chairman Wade Noble is at the helm facilitating the meeting. The recording the meeting is being recorded, and the web link will be posted in the chat box. Look for it at the end of the meeting. Zach will post that where you can find the presentation slides and the meeting recording. Also, for your information, we do save the chat. First, we have very quickly that screen that's been in front of you, some ground rules here. If you do have video capabilities, we would love to see your face. It helps it make more like a person-to-person meeting, although kind of far-fetched. As I said before, if you have not muted your computer, if you're using your phone for audio, you need to mute your computer, please, or else sometimes we have this horrendous feedback noise. And when you are not speaking, you will be muted. Continue to keep yourself muted during the times when you're not speaking. We'll have better audio. If you would like to speak, just type that in the chat box, and when we have the time, when we have the opportunity, Zach will unmute you, let you know when you're unmuted, and then it will be your turn to speak. If you prefer not to do it that way, you can always just type in your comment or your question in the chat box, and Zach will read those. So I'm going to take a minute here to pass the presenter over to Zach, and he is going to give us a little tour around the WebEx site. Okay, Zach.
Okay, so I'm going to go ahead and share my screen here so you can see what I see. All right, so as you can see, I have a lot of folks in gallery view here, but I can actually change who I'm witnessing by changing the little icons at the top of my screen in the upper right-hand corner. I can do several different views. I can just have the active speaker that's on, or I can do a grid view, so I can see multiple people at once. So right now I have Wade pinned here, and I can unpin people who I don't want to see. For example, I can actually pin myself here. All you see is me. Now on the icons in the bottom of the screen, there's a mute button, mute unmute function, and you're going to want to red, just as I pressed just then. When it's red, that means you're muted, and we want to keep it that way for the duration of the meeting, unless you would like to actually speak and comment. There'll be a time for that, and Wade will call for people to make comments or ask questions. In that time, I will unmute you when it's your turn to speak, if you'd like to speak. So you can see on the right-hand side, I actually have all the participants here, and I can unmute people using that icon on the right-hand side. And then when you finish speaking, I will mute you. So don't bother too much with this mute button over here. We'll take care of that piece. And it eliminates a lot of awkwardness if I'm trying to unmute people and they end up muting themselves because they think that it's in their responsibility to do that. So it just kind of keeps the responsibilities of that function just within our section here. And of course you have the video function there, and then the participants. So you can actually close the participants window if you like, or keep it open. And then the chat box. The chat box is pretty important. We keep this chat box open because you can actually see the comments that people are making. Those comments I can read to the chairman and for everybody else to hear. And if you'd like to have your comment read by me, I'll do that at the appropriate time. So just type that in the chat box there, and I'll read them in order. So whoever did it first prior to everybody else, I'll just go down the list. If you want to actually speak and have yourself unmuted, just type your first and last name in the chat box. Now reserve your place in line to speak to the chairman or the presenter. And with that, I think that's pretty much all the functions here. You can also, just in case, if you want to make the slides a little bigger, you can actually control the size of the window by just putting your cursor over this little line here on the right-hand side. Big or as small as you like. Okay, did I miss anything, Cindy?
That's it. I will get back
So
to our slide
sharing, and I'm going to pass you the ball. One second. Make this window a little bigger. Okay, there we go. All right, the ball is yours, Cindy.
Okay. Okay. Are we back to the slides? Can everybody see the meeting agenda?
No.
Okay. Hang on just a minute. Okay, are we seeing the agenda now?
Yes.
Okay, I will now, Chairman Wade Noble should be unmuted, and it's all yours, Chairman.
Thank you very much. Cindy and Zach, we certainly appreciate all the effort you put into making this meeting happen. I know it's taking a lot of work, and again, thank you very much. To those who are on the line, welcome to the first webinar only Governor's Water Council Long-Term Water Augmentation Committee meeting. As Cindy mentioned, this meeting is being recorded. These committee meetings are open to everyone, and all attendees can feel free to participate in the discussions. In lieu of introductions, you can view the participant list in your side panel to see who is attending. This committee published the long-term water augmentation options for Arizona report in August 2019. The report offered the water users and planning communities across Arizona a toolbox of possible augmentation strategies for their consideration. Even though that project came to a close, our committee continues to explore water augmentation options not analyzed in the report. Today, we will have 3 presentations for potential water augmentation options. Weather modification by Chuck Cullum of the Central Arizona Water Conservation District, forest and grassland management, with one presentation from Marcos Robles of the Nature Conservancy, and another presentation from Bruce Hallen of the Salt River Project on SRP's future study plans. The final presentation will be Phreatophyte Management by Sarah Porter of the Kyle Center for Water Policy. All of these topics will focus on research and science-based results relating specifically to water yield or water supply. Each presenter is given 15 to 20 minutes, followed by an up to 15-minute opportunity for the committee to comment, question, and discuss. The presenters will aid the committee in understanding the issues, science, challenges, and opportunities of each method. The objective and desired result of these presentations is for the committee to discuss the feasibility of each option as an augmentation strategy to be a recommended addition to the toolbox of feasible potential methods or strategies. We want to be able to answer the question, should this augmentation strategy be added to the Arizona toolbox as a viable consideration for communities? As part of that, we want to know, does the potential strategy need more research to answer that question? And if so, what do we need yet to know? Or is it just not a feasible tool to add to the toolbox? And do the benefits now or potentially in the future of the additional water it provides outweigh the costs? Our first presenter is Chuck Cullum. I can get this whole title out, Chuck, I know. Colorado River Programs Manager for the Central Arizona Water Conservation District. Those of you who don't know Chuck, he is leading this group simply because he probably is the one most knowledgeable on this particular topic. And those of you who've worked with Chuck over the years understand he knows what he's talking about. Take it away, Chuck, on weather modification.
Got you unmuted, Chuck.
Thank you. Chairman Noble, thank you very much. And I congratulate you for being the first outdoor office participant I've observed since we've been meeting remotely. So you are the smartest of us as far as I can tell. Good for you. I was asked to provide an overview of the current understanding of snowpack augmentation, also known as cloud seeding or weather modification. And the technology was observed in the late 40s through experiments by researchers in atmospheric science at General Electric, of all places. And they observed that introducing aerosols, an aerosol is really a term that describes a molecule about a substance about 10 microns that is airborne into a cloud. So GE introduced aerosols into a cloud and observed an increase in precipitation in their experiment. In the Colorado River Basin, as you can see on this slide, the snowpack augmentation was identified as a regional opportunity to address long-term risk, water supply risks in the western United States. That was explored in 1974 in what Reclamation terms its West-wide study And the West-wide study was Reclamation's response to a requirement in the 1968 Colorado River Basin Project Act for Reclamation to study and identify opportunities to augment the Colorado River system. The West-wide study identified a large magnitude opportunity to increase snowpack and therefore runoff in the Colorado River system. That was followed by a proposal in 1982 called the Colorado River Experimental Snowpack Test, or CREST. And that program had a whole, it was going to be an 8-year program. They operated for 1 year, and then budget cuts eliminated CREST. But Reclamation did operate snowpack augmentation as a pilot project in 1982. The upper basin states of Colorado, Wyoming, and Utah have operated and regulate snowpack augmentation programs since the late 50s. For Colorado, a program began in 2005 in Wyoming, and Utah has had a program underway since 1952. There was a snowpack augmentation study in an experiment conducted on the Mogollon Rim in 1992. The Arizona Department of Water Resources, Reclamation, and others participated in that study to evaluate whether, even in the warmer climates of central and northern Arizona, to explore whether snowpack augmentation was viable. The technology has been recognized as a low-cost method to increase snowpack and runoff across the western United States. In fact, California and Idaho hydropower producers have invested in snowpack augmentation for 50 years. In fact, the two largest continuous programs in the U.S. are in California and Idaho and have been operated by hydropower companies. As you might expect, for every dollar invested in a headwater snowpack system, snowpack augmentation system, the hydropower generators have multiple opportunities as the water cascades down through the watershed to get a return on that investment. In fact, Idaho Power is expanding their program into the headwaters of the Snake River, the Salt Range of Wyoming, which could have actually a benefit to the Colorado River system as well. The most extensive study of snowpack augmentation and attempts to quantify the results were completed by Wyoming in 2014. The study ran from 2005 to 2014. It was a partnership between the state of Wyoming, the University of Wyoming, the University of Colorado, and the National Atmospheric Research Center based out of Boulder. So there are lots of misunderstandings about snowpack augmentation, but I hope that through the course of this presentation, folks will begin to understand that the science has evolved dramatically and is an interesting opportunity for this group to discuss further. Next slide, please.
Getting there.
I do want to note that a lot of this content was prepared by Dr. Mohammed Mahmoud of Central Arizona Project. He presented this information to the CAWCD board, I believe, in February, and he also serves on the North American Weather Modification Council as president of that organization, which is a regional group of operators and researchers of weather modification technology. So we want to talk about the science and application of winter cloud seeding for the purpose of snowpack augmentation, explore the efficacy of those programs, talk about potential extra area effects. The layman's term for extra area effects is cloud wrestling. The concern is that if you take moisture out of a cloud system, does it have a downwind negative effect in the region? We'll talk about that. Environmental impacts from cloud seeding. The most common seed material is silver iodide, and there are questions that people pose about long-term environmental impacts. There's research that addresses that. And then finally, I'll cover the most recent information, which I think you'll find interesting and compelling, about some work that was completed in 2018 and in fact this year on the demonstration of introducing aerosols into a cloud does indeed trigger increased precipitation, and then new ways to quantify the results. So next slide, please. So one of the things to keep in mind is that cloud seeding does not generate clouds. So you need appropriate meteorological conditions to generate increased snow, increased precipitation over the target area. So you need a storm front, a winter storm front that is persistent enough over the target area to generate increased snow production over your target. These are typically regional winter storms. We call them orographic storms. They are the typical continental-wide low front that moves from west to east across the region, typically the northern and central Rockies. As those storm events encounter the topography of the Rocky Mountains, they're actually squeezed. That compaction creates more opportunity for snow. We need clouds. We need relatively slow moving storm systems. They need to be on the trajectory so that they're going to encounter where we have set up seeding locations, and that they're going to bring moisture over the target area. Temperature is very, very important. So we need what's called supercooled liquid in the cloud itself. And we're looking for temperatures on the order of -8 degrees Celsius, which is somewhere between 15 and 20 degrees Fahrenheit. This is especially true for silver iodide. So we will monitor the storms and track their temperature to see if they have that supercooled liquid, which would be the target for the cloud seeding material. And I'll talk more about that in a minute. And then we need sufficient moisture in the system so that it's worth the effort to turn on the generators and try and increase snow. Next slide.
Testing.
Who's testing?
Got you, Marcos. Thanks. We're just making sure this mic works.
Okay.
Sorry about that.
Next slide.
I'm getting a slow reaction to advancing the slide.
It's a supercooled liquid slide moving slowly.
It is. There we go.
All right. So this is a graphic that's used quite frequently by the North American Weather Modification Council to talk about how snowpack augmentation works and how the programs in the Western United States are operated. So in the winter season, regional storms track from west to east. They encounter in step one a topographic barrier like the Rocky Mountains, the Mogollon Rim, the White Mountains, etc. As that moist air encounters that topographic barrier, it rises over the mountain, cooling the bottom layer, and creates the presence of supercooled liquid. Usually that occurs for most winter storms in the western U.S. at about 8,000 feet and higher elevation. The second step is that when those critical conditions are met, that is, the winter storm is in the right place, it has sufficient moisture and supercooled liquid, then we turn on what are called generators, and essentially you burn silver iodide at elevations, these are ground-based generators, at elevations above 8,000 feet. So you're actually in the bottom of the storm layer. If you've skied at Snow Bowl or Sunrise, when a storm comes, you know, you actually ride up into the cloud base in many of those storm events. So we have generators at 8,000 feet of elevation and higher. You burn a flare with silver iodide dripped into the flare. That silver iodide is carried by the warm air up into the base of the cloud. And that silver iodide is the right molecular size to trigger what's called nucleation. That is ice, the supercooled liquid, which is liquid moisture in the cloud, needs to encounter an aerosol of about 10 microns, that's the molecular size, to trigger ice nucleation, transitioning from wet liquid to ice, which will then fall as snow. So item 2 is when the right conditions are met, you induce silver iodide into the base layer of the cloud. Item 3, the silver iodide provides the ice generating nuclei for the supercooled liquid to turn from water to ice. And then step 4 is those freezing droplets bounce into other supercooled liquid and grow into snow crystals or ice crystals and then fall to the ground when they're large enough and increase snowpack. I want folks to keep in mind that cloud seeding is a catalyst to increase the naturally occurring processes in the clouds. These clouds are likely going to snow some amount, but when you put more aerosol into the cloud, it's a catalyst that generates an amplification of that snow generating event. So we need the right storm, the right temperature, the right wind trajectory to turn on our generator, and then to generate additional snow in our target watershed. Next slide, please. So you've heard me talk about supercooled liquid and nucleation or ice generating nuclei. The atmosphere physics of it are relatively straightforward. So there's liquid in the cloud. It needs a something of the right size to cling to generate ice. So that's what this is attempting to describe, is you need a particle of cloud condensate nuclei. And this is what climate scientists, folks who are concerned about climate change, the aerosols that they're concerned about are the right molecular diameter to generate more clouds. So this is, the current state of thinking in a broad range of atmospheric science, not just snowpack generation. So the bottom part of this slide describes that when a storm front passes, it has the moisture volume in the cloud. Only about 20% of that moisture content in the cloud is condensed cloud water, or that is liquid phase moisture in the cloud. When most studies suggest that what falls out of that portion of the liquid water vapor is about 6%. So when we induce an additional aerosol into the cloud, we're really getting about 1% additional moisture out of the cloud. But you have to keep in mind that these are giant rivers of moisture moving across. So 1% of a lot is what we're really targeting here. So we're just, again, amplifying the natural occurring process in the cloud and making that cloud a more efficient producer of snow. Next slide, please. So what does it really look like on the ground? In the West, we use predominantly ground-based generators, flying small planes that are trying to generate ice and snow into a mountain range in the winter is probably not a healthy long-term adventure. So we use mostly ground-based generators, and the generators are relatively straightforward. The graphic on the right is in the Wind River Range in Wyoming, and it has starting from the left side of that photograph, there's a solar panel that provides electricity power to all the data gathering and monitoring devices. At the top of that panel is a supercooled liquid measurement device. So as the base layer flows over it, it measures the temperature and the moisture content of the cloud. It transmits that information to the operator at a remote site. There's also an anemometer, which is a wind speed and wind indicator. Behind it, you see a propane tank. That propane tank is going to fuel the flare or the burner. The green box at the top of the tower, and that tower is about 30 feet in the air. That's basically where the fire, where you actually set the silver iodide on fire. The silver tank is caged, and that's where the silver iodide resides. So when the operator observes the right conditions, supercooled liquid, wind trajectory, and moisture content headed in the right direction, they'll turn on the flare, which is shown in the bottom left photograph looking down. So the propane tank has a spark, the flare has a spark, propane turns on, silver iodide is burned in the tunnel, and it flows up into the base of the cloud. At each site, over the course of the year, about 2 to 3 kilograms or about 10 pounds of silver iodide are released over the course of a season. So we're not putting a lot of material in the cloud, but enough to trigger increased ice creation. And Wyoming operates about 30 of these in the Wind River range for the purpose of augmenting the Green River, a tributary to the Colorado. So in the bottom left, you can see that cloud seeding works because there's snow on the ground and the flare's on. So Wade got that. Nice job. Next slide, please. So Wyoming, the state of Wyoming has uses a surcharge on minerals and petroleum that's generated in the state of Wyoming to fund water and water augmentation projects. As part of that funding, the state of Wyoming funded and participants from across the basin, including CAWCD, California agencies, and Southern Nevada agencies, funded and participated in their weather modification pilot program and experiment. The essence of it was to determine if there's a statistical difference between seeding 2 parallel mountain ranges to see if you seed one range on the same storm, do you see versus a parallel storm or a parallel mountain range, do you see an increase in snow production between similarly situated mountains, one seeded and one not seeded? They ran that experiment for 2005 through 2014, and they operated in the Wind River Range, the Sierra Madres, and the Medicine Bows. The Medicine Bows and the Sierra Madres generate runoff into the Platte system, whereas the winds have headwaters of the Green. Next slide, please. So what did the study determine? That at a minimum, they observed a 3% increase in precipitation. When they dug deeper into those data, they observed some unintended downwind effects between the Medicine Bows and the Sierra Madres. And they also looked at several seeding events where there was insufficient burn time. When you pull those data out and look at it, you reassess it, you see between 5 to 15% increase in precipitation from the cloud seeding range versus the unseeded events. It's conducted by the leaders in the field. It's a well-respected study that suggests that there is a demonstrable benefit of winter orographic storm cloud seeding to increase snowpack. Next slide. So there are two principal concerns about weather modification for snowpack augmentation. One is extra area effects or cloud rustling. Are you robbing snow from a neighboring state or a neighboring watershed? There have been a number of studies on that. Hunter in 2009 did a literature review. Basically, he observed that it's it's more often the case that you see a positive downwind seeding effect outside of the target range, meaning it's rare to see a decrease in precipitation downwind versus the statistical average, and that should make sense if you've got not all of the ice nuclei that you introduce in the cloud drops out over your target area, because not all of it persists long enough in the cloud to grow large enough to fall by gravity into your target area. So you should expect some positive benefits. And these are, I'll use a technical term, these are ginormous moisture events. So the scale of the amount of moisture indicates that it would be hard to dry up a cloud from one cloud seeding event. The second and related question is, can you generate too much snow? And therefore thereby cause increase in avalanche risk, snow removal costs, plowing, and damage to houses, road plowing, etc. All of the programs in the Western United States are regulated by state agencies in those states and have what are called suspension criteria, so that if the snowpack exceeds some percentage of the long-term average, then snow augmentation programs are suspended, that is turned off, so that you're not adding more snow to a snow-rich snowpack. They're usually, the suspension criteria that I'm aware of in Colorado are usually around 125 to 130% of average for that day. So again, there are protections in place to avoid the extra area effects from snowpack augmentation. Next slide, please. The second most frequently asked question is, what about the environmental impacts of inducing a heavy metal silver into the environment? The background levels of silver these are in parts per billion. The background average in surface waters are 2 to 2/10 of a part per billion. The EPA drinking water standard is 100 parts per billion, so there's not much observed in the environment. There have been a number of studies in Nevada and Colorado about the exposure, that is the accumulation of silver in the environment in areas with long-term cloud seeding. And what they observe is that there is very little increase. It's hard to find the silver in a seeded area, which makes a lot of sense. You're not putting, if you're putting 10 pounds of silver into a cloud, and it falls over an area the size of the headwaters of the San Juan River, you wouldn't expect to see a lot of accumulation, and that's what the studies show, that it all stays within the observed background in the seeded area. And EPA did a study in the 80s in advance of Reclamation's CREST program that came to the same conclusion. Next slide, please.
Hey, Chuck, this is Zach. Just so you're aware, we're kind of starting to get into Marcos's presentation time at the moment.
This This is the last slide.
Got it. Thank you.
And it's awesome. So in 2018 and 2020, two studies were released through the Journal of the National Academy of Sciences, and I wanted to pull two quotes from those, from the conclusions. First is in the 2018 study, they actually have radar signature of the cloud seeding plume generating ice and snow in the cloud falling in the target area. So there's direct observational evidence in what's called a seeding signature that these ground-based generators are increasing ice in the base layer, and that ice is falling to the ground as snow. That's a significant improvement, basically, because it's a direct evidence that aerosols in a cloud generate more snow. Then the second paper, which was released in February of this year, is states that using the direct measurement techniques, that they are unambiguously the results of cloud seeding in regions with light or no natural precipitation. It was kind of a crazy experiment. They seeded clouds that in areas where it rarely snows, and they made it snow in a demonstrable, measurable way. So because of the science and technology, cloud seeding for water augmentation appears to be viable and has a long history in the Western U.S. It will not ameliorate a drought because you need storms, but in near normal and slightly above normal years, it is the data strongly suggests that it can increase snowpack from 5 to 15%, which will generate more runoff. Thank you.
Chuck, thank you. Turn me on, somebody.
I hear you, Wade.
Okay, thank you very much for your presentation. And to all of you who got introduced to spatio-temporal evolution, you're better off than when we started. We're going to skip the questions for right now and hold them till the end. We're going to turn the time over now to Marcos Robles from the Nature Conservancy for his presentation.
Hello, this is Marcos. Can you hear me?
We got you, Marcos.
Great, thank you, and thank you for the opportunity to present this information this morning. My name is Marcos Robles. I'm a conservation scientist with the Arizona chapter of the Nature Conservancy. Today I'm going to talk about our work on forest restoration and accelerating it in order to address some challenges we have. But I'm going to talk about the potential co-benefits or incidental benefits on runoff. In the background picture here is a picture of our ponderosa pine forests and how they looked historically, and you'll notice the kind of the open park-like nature of them, and that will be an important point as I go on. Next slide, please. So the context here is we're working on forest restoration in northern Arizona in the ponderosa pine forests of Flagstaff and Show Low area. Those are shown in green, and in the last couple of decades, there's been about a 20% mortality of these forests associated mostly with high severity fires. That's the areas shown in red. Two of the largest fires in state history have occurred in the last 20 years. And this is of concern because these headwater forests provide about 40% of Phoenix's water supply. And so what is happening currently is that the forests are experiencing a regional drying trend due to a combination of recent drought conditions, warmer temperatures, but also these dense forests that I alluded to before. And that's the one factor that we have control over, at least as land managers, and that will be the topic of this presentation. Next slide, please. So the question we asked is in the study that I'm going to highlight is just a basic question of, can big efforts like the Forest Restoration Initiative improve not only forest resilience in terms of reducing fire risk, but also have co-benefits in runoff. So the Forest Restoration Initiative is shown in the map in the dark green outline. It's an effort over the next 10 to 20 years to restore millions of acres of ponderosa pine forest in order to primarily reduce the fire risk, those big fires that I showed earlier. But we wanted to ask, what are the co-benefits in terms of water? Just to give you a thumbnail picture of what we're talking about, the restoration will reduce the density of forest in the upper left-hand picture to something that looks like the lower left-hand picture. And in terms of water, what we think might happen is you have a lot less straws, a lot less trees in the soil that are extracting water, and potentially, therefore, less losses and more for runoff. Next slide. So this study that I'm going to present was published in 2014, where we basically looked at the Salt and Verde watersheds shown in the map, and looked at the ponderosa pine forests in those watersheds, which are shown in green. They only cover about 20% of the watersheds, but they're responsible for about 50% of the runoff, so they're really important. And they happen to be the main forest type that is going to be restored in the Forest Restoration Initiative. That's shown in the red area. Now, another important aspect of this map is the dark gray watershed called the Beaver Creek watershed. We based our study on empirical field studies that were conducted in this watershed in the 1950s to 1980s using paired watersheds. So in one watershed, forest treatments were performed. In the other watershed, there was control with no thinning, and they had infrastructure like in the lower right-hand corner to measure runoff differences between these two watersheds. So it's empirically based. It ran for about 30 years, and so our study is based on that study within our watersheds. One thing that we know is important to understand in terms of how much runoff there's going to be in a given year is just how variable our climate is. So we ran our scenarios looking at very dry periods in the historic record, as sort of shown in the lower left in the drought period, as well as pluvial or wet periods. So what would be the difference in runoff if thinning occurred in either one of these periods? Next slide, please. And so this is our main result. Basically, we found a 20% increase in all of the scenarios that we ran, 20% increase associated with simulated thinning. So in this graph, the x-axis, the zero line, is basically an increase from the unthinned forest, the paired watershed where there was no thinning. So these ascending dots suggest an increase of runoff on the y-axis with thinning. Now the runoff increase was lower in the lower left-hand side when it was a drought period, and it was higher when the period was wet. But in general, they were still about 20% increases from kind of the control unthinned stands. So that was an important result. And from that, I'm just going to move to the next slide. And so I'm going to try to address some of the questions that were asked of us by the panelists. And the first one is, is there empirical research to support forest management effects on runoff? And that's why I wanted to present this study. To summarize, we found about a 20% increase, potential increase in runoff in the headwater watersheds, the ponderosa pine watersheds where this thinning occurs. Now those potential increases are more modest as we increase the scale. So that would amount to perhaps a 1 to 9% increase in the municipal water supply of Phoenix, and perhaps a much smaller 1 to 3% increase of the Salt and Verde River flow on an annual basis. Again, these watersheds are very large scale, and the restoration, if you remember that red footprint of the ponderosa pine, it was still relatively small compared to the full extent of the ponderosa pine. This is an empirically field-based study based on a sub-watershed in our area. And so we think it's applicable to northern Arizona ponderosa pine forest and restoration efforts in those pine forests. In terms of other studies, I found 3 other studies that were based on simulation models. 2 that evaluated the Forest Restoration Initiative of FORFRI, 2 by ASU professors, and 1 by University of Arizona. And they each showed a modest increase in runoff associated with thinning, similar to our study. Now, these are simulation models, so they're based on empirical data, but they sort of simulate the processes such as evaporation and those sorts of things, snowpack. You know, our study is really focused on primarily forest resilience, and there are plenty of studies that show that this kind of forest thinning will actually reduce the risk of these what are called crown fires. These are fires that go all the way up to the top of the crowns of trees and results in sort of 100% mortality of trees. So they are effective to reduce that. Another study have found that they are effective in actually reducing evapotranspiration losses. Again, that's the straws in the ground that are removing soil moisture into the atmosphere and leaving less for soil, leaving less for runoff. So there is one study that shows that. Next slide. In terms of the other 2 questions that was asked of us in terms of implementation and cost-benefit analyses, I think that in this topic, we fall into the realm of additional research needed. This was one study based on historical empirical data. And one of the outstanding questions from that research is how durable are these treatment effects? So what the historic Beaver Creek experiment showed is that after about 6 years of the initial thinning, the forest regrew. And as you get those small trees regrowing, they're taking out the additional water that was turning into runoff and leading to no change between the thinned and the control watersheds after about 6 years. So one of the plans with the FORFRI restoration project is after these forests are initially opened up with thinning, that those openings would be maintained with maintenance prescribed fire burns. There's reason to think that therefore the runoff benefits could continue, but that just hasn't been researched empirically and is a need. We need to figure out what happens in those cases. Also, temperatures in the last several years have been a little bit warmer than those historical experiments. So we and others are looking at how that affects snowpack and how that might affect stream flow. And then we are also working on actual restoration plots in and around Flagstaff. And we're working with researchers at Northern Arizona University, and SRP has also been involved on this, where we've instrumented those forest stands to look at the effect of thinning on snowpack levels and soil moisture levels. Those are 2 key determinants of stream flow. In terms of cost-benefit analyses, I'm not an expert on economics or cost-benefit analyses, but I just would like to draw the group's attention to there's been several studies that have looked on the forest and fire end, what the cost of preemptive forest management is versus the cost of post-fire recovery, including recovery or rehabilitation of water infrastructure. And the short story is it costs much less to do the preemptive work than it does to clean up after. Part of any cost-benefit analysis is also looking at what the risk is, and there are several really good products that look at what the wildfire risk assessment is. Again, the wildfire risk is, yes, it's about the forest, it's about fire, but it will also affect potentially water quality. So with that, I know I'm sharing my time with Bruce at SRP. I think I'll stop there and transition to Bruce.
Thank you very much, Marcos. Excellent. We appreciate you. We're going to turn the time over now to, as it says on the slide, Bruce Allen, Director of Water Supply for the Salt River Project. Bruce, take it away.
Thank you.
Okay, thanks. Thanks, Zach, and thanks, Cindy, for the opportunity and for putting this together and the opportunity to make this presentation. And Marcos, we appreciate the partnership and working together with TNC on forest health and monitoring impacts on the watershed. So if I could go to the next slide, please. What I thought I would do is, we don't have a lot of results to share with you at this point, but what I'd like to do is kind of go over the research and the studies that we're conducting within the watershed. I will say that over the period of record, and we've been keeping records at SRP since the late 1800s, we have not seen any real appreciable differences in runoff based off forest conditions. And so while we recognize there's been a variety of modeling efforts that have been done, not only in Arizona, but throughout the West on pre and post restoration, we're still not convinced that, or we want to better understand when you do have restoration and post restoration values, what exactly happens to that water and that water supply. And so as I go through this presentation, I talk about the impacts of pre and post restoration on the watershed and the water supply. I'll use the term more of water balance because we're not sure if that water makes it into the river system itself, but it very well will make it into the ecosystem. And what I'm referring to is the water balance. So you're improving the hydrology of the system, whether it's springs or whether potentially could be the groundwater in the aquifer itself. And so our objective here is just to gain a better understanding of the impacts of forest restoration on the hydrology of the watershed. And it's very much based off data collected on the ground, applied information and data. And so from our perspective, this is going to be a very, very long-term effort. We started collecting data on the ground 7-8 years ago on the Sycamore watershed. We've expanded to also on the Creek watershed, and we're doing some additional work on Cragen watershed. And so those are the three study areas. I'll describe, the type and extent of data that's being collected because there's a lot of variables associated with water and evapotranspiration and how that water ultimately might make it into the watershed and the stream system. And then I'll also describe some of our research and modeling efforts. So with that, next slide, please. This is essentially an aerial photo. And if you look at the left-hand corner of that aerial photo and you see that green outlined area, that's the Verde watershed. And I'm going to be discussing three projects, as I mentioned, the Sycamore Creek watershed, where we're really going into a lot of detail and trying to get a better understanding of what happens to that water balance. The Beaver Creek watershed is a study that's complementary to the Sycamore Creek watershed, but much of the Beaver Creek watershed, as Marcos mentioned, has a lot to do with analyzing snowpack and snow sublimation and snow cover and how that impacts flow on the Beaver Creek watershed. And then on the C.C. Cragen watershed, we have much of that focuses on the resource characterization of the forests and removing trees and what processes might be best in order for us to get an understanding of pre and post forest thinning and how we might be able to apply it across the entire watershed. What I would like to point out, and this is kind of interesting, when Marcos mentioned the two major fires that occurred on these watersheds, he mentioned the Wallow Fire, which is in the Salt River watershed, which is distinguished by those red lines. But if you look at where it says the Mogollon Rim, and you look at that area that seems to be devoid of trees, essentially that is the Rodeo Chetaskai. That area still has had trouble recovering when it comes to the forest. And so I just thought that was very interesting. When you look at this slide, you can see the impacts of that fire that occurred, close to 20 years ago, 15 years ago. So next slide, please. This depicts much of the modeling that's that we're dealing with associated with the research and analysis. If you look at essentially the blue arrows are essentially water into the system. So you have precip falling from the sky. And the thinning of the forests in this model really will reduce the canopy interception of that water. So whether it's snow or whether it's rain, and thus, there'll be losses from that canopy due to sublimation or evaporation. But it also exposes the subcanopy to more wind and sunlight, which then will increase potentially evaporation losses from the surface. And so we want to better understand that relationship, and we're doing some modeling work together with Arizona State University to really get a representative on the sample of those trade-offs and how these competing processes might alter actual water balance within the system. And so we're looking at elevation aspects, kind of slopes, et cetera. So the research questions in and of themselves is, how does thinning change the forest water budget, and how large are these changes relative to those due to a changing climate? Because as Marcus mentioned, we have seen some warming conditions on the watersheds over the last 50 to 60 years. Next slide, please. On the Sycamore watershed, we're collecting a wide variety of data and a lot of information. We did some LiDAR work, and I don't know those of you that are familiar with LiDAR, but it's a laser light remote sensing device that really measures distances. And through that measurement of distances, you can really get returns and wavelengths that make a 3D representation of the ground itself. At this particular site at the Sycamore watershed, we were taking 30 measurements per meter to get a better understanding of the forest infrastructure and the topography itself. We've also installed photography, and I'll talk a little bit about that, but we have 7 years of data on the ground where we've been collecting information. So that photography data will also be an input into the modeling that ASU is doing for us. We have 7 sites monitoring over the last 7 years. There'll be 10 model inputs. From the photography site, we're looking at stage and stage. I'll display that in the next slide and talk a little bit about that, but also some calculated discharges that we have over the last 7 to 8 years, precip, soil moisture, and then we also have some images that we're employing as we do the evaluation. On the LiDAR end of the piece, we're looking at leaf area index. And, what the heck does that mean? Well, it really looks at pine needles, and pine needles emit some light and really LiDAR will essentially take the light that it's emitted by plants so you can get an understanding of the coverage of that vegetation. But this variable essentially will predict evapotranspiration. And evapotranspiration in the number of plants also impact wind speed and also impacts radiation to the earth, so evaporation. We'll look at a bare earth model, and the bare earth model is really a 3-dimensional representation of the terrain. Also looking at tree canopy height and tree coverage, because post and pre-thinning and post-thinning will actually stems and trees that are being removed versus those that were there pre-thinning, so we can get a better understanding of the evapotranspiration rate. The false color imagery is really just a basic land cover visualization, and it'll really show when forest restoration occurs. And then this last item is really used to quantify vegetation by measuring the reflection and absorption of different light. And so it's very highly technical, giving you a lot more detail on the structure and then what the impacts might be ultimately on the watershed. Next slide, please. The photography. Photography is kind of an interesting new technology that we've been utilizing, especially at those sites that are hard to reach, that are remote. And essentially what we're doing is that we're taking photos of flow. And for these shots, this is on the Upper Sycamore watershed. But essentially, these ephemeral streams are very, very flashy. And the peak of the flow many times would be reached in time periods when we really can't calibrate those sudden changes because we don't have equipment in the field. And so essentially what we've did is that we've put in an event gauge, and you can kind of see that circled there under the number 2 images. And that event gauge, along with we have a transect of the size of the area where the flow is occurring, we can estimate the actual flow itself. And so we have this data for these sites throughout that Upper and Lower Sycamore watershed. And we have that data. We're collecting that imagery for every 15 minutes. And so we can also get an understanding of changes with the vegetative patterns. We're also doing this with snow and snowtography, where we're taking pictures. We have a transect where we're taking pictures at different elevations when it comes to snow cover, how much snow is falling at various elevations, how long is that snow staying on the ground, and then changing vegetative patterns. Much of that has to do with, as we're looking at changing climatic conditions, what kind of impact is that having on snowpack and the length of the snowpack and the duration of that snowpack. Next slide, please. This slide is really focused on the Beaver Creek forest thinning and what we're doing at Beaver Creek. And Beaver Creek is more of a study on snowpack and impacts of pre and post thinning on snowpack. If you look at the depiction on the right side, you can see that an SWE is snow water equivalent. So that's how much water is really within the snowpack itself. And ablimation is really just the evaporation or the removal of the snow or ice through melting. And so essentially what we're trying to get a better understanding of is as you remove those trees, you do have more snow that's reaching the ground, but at the same time, you have the potential for more evaporation associated with that snow on the ground. So we're trying to get a much better understanding by doing work in the field at Beaver Creek to get an understanding of, with snowfall and with snow melt, pre and post restoration, what kind of impacts are we having on stream flow? Next slide, please. We're hoping to have some results on this next summer on the Beaver Creek analysis and on the Sycamore watershed preliminary analysis, probably late spring of this next year. For Cragun's a lot more detailed analysis just on forest infrastructure. Cragun's a critical watershed for us. It's a watershed that has 64,000 acres of a landscape that is highly susceptible to catastrophic wildfire. And so we want to move as quickly as we can to get in and thin those areas. But at the same time, we want to get a better understanding of that forest structure. So we're doing a lot of work in better understanding the forest inventory. And we're looking at 2 different analysis methods so that we can better estimate the forest infrastructure. So we're working together with the Forest Service on their forest inventory data and together with NAU to get a better understanding of the forests and some of the water and carbon benefits associated with pre and post restoration. And so if I could look at the next slide, please. I thought I'd just touch on some carbon work that we're doing associated with restoration. And what this graphic shows is that the blue line is really the basis following restoration and the carbon capture associated with those forests. The red line is if you weren't to thin the forests themselves. So you see this increase in carbon. Essentially, the forests are absorbing carbon, but ultimately those forests are going to burn. And so you see that significant drop at the red line associated with that loss of carbon now. And so that delta between over this 40 time period that we're looking at, that delta is essentially the carbon benefit associated with restoration. We did a case study and a methodology work together with the National Forest Foundation. And essentially the estimate is that there's about a 26 ton per acre benefit associated with each acre when it comes to forest restoration. So we're working a little bit further on that model, trying to develop some additional methodologies to compare results and apply to a restoration project to build an understanding that there are also not only potential water benefits and the water balance associated with these restoration projects, but also carbon benefits. Next slide, please. This is really a summary of what I spoke to, and each of these projects, could be a presentation in and of themselves, but from a piece perspective, this is very much a long-term analysis. As I mentioned, we anticipate some results in the spring of 2021. There's a lot of data that we're going to continue to gather, especially on the ground data gathering. We're going to continue to monitor and report on trends that we're seeing. There's still a lot of uncertainties associated with the variables that we're monitoring, evaporation rates, evapotranspiration rates, infiltration. We're looking at soil moisture, do the evaporation transpiration rates, as you remove trees, does that difference between evaporation, transpiration, and having more snow potentially on the ground or having more precipitation enter the system, do the evaporation rates overtake that because now you have more exposure to the ground, you have less of that area being covered by the forests? Infiltration, are we going to see an increase, less infiltration, or is it going to be neutral? And then as Marcus mentioned, this just doesn't happen overnight, and you have to have this continued ongoing vegetative management, adaptive management scheme. So as you go through the thinning, you're going to have to continue to manage that vegetation to ensure that not only do you avoid fire, but you continue to receive these benefits, potential benefits associated with water and carbon. So I went through this very, very quickly. Happy to take questions following our last presentation. So thank you.
Thank you very much, Bruce. We appreciate you. Good job. We're going to turn now to phreatophyte management. You thought Chuck was good in presenting new words. These phreatophytes always love us. Anyway, Sarah Porter, Director of the Kyle Center for Water Policy. Sarah, take it away.
Well, thank you, Wade. I want to start by mentioning and thanking Cindy Rule, who assisted, not just assisted, was a partner in developing the report that we have for you today. Next slide. So this is the approach that Cindy and I took to looking into the question of whether phreatophyte management is a strategy that we should be pursuing as a committee to augment the water supply. We did a literature review, conducted a literature review, and we interviewed a group of experts. We didn't reach all of the experts we aspire to interview, and we hope to continue to reach out to experts. For the record, we spoke with Kelly Mott-Lacroix, who's the chief hydrologist of the Tonto National Forest, Holly Richter, hydrologist for the Nature Conservancy Arizona, Osvaldo Sala, an ecologist at Arizona State University who works and was kind of speaking on behalf of himself, and Enrique Vivoni, another ASU researcher, and then Chuck Paradzik and Ruth Valencia of SRP. Holly, Chuck, and Ruth are participating in this meeting, and so it's wonderful that they're present and able to answer questions of science that may come up. We still hope to reach a few researchers that were mentioned to us over and over again. Pam Nagler at USGS, Abe Springer at NAU, David Goodrich at USDA, Russell Scott at USDA, and Ben Bloodworth at Rivers Edge West, used to be known as the Tamarisk Coalition. And as for the literature review, there is an immense body of literature about phreatophytes and water. It goes back decades and decades and decades, probably a century, maybe even more than a century. Cindy has prepared a beautiful bibliography that we can, I think the best approach is to post it on the Governor's Council website document space for this particular committee. We welcome suggestions for additional literature to add and additional experts to consult with. Next slide, please. So let's start out with the vocabulary, as Wade mentioned, and that is, what is a phreatophyte? Now, every scientist that we spoke with asked us that question and made sure to correct us because they wanted us to know we weren't necessarily talking about phreatophytes. And so we understand that. A phreatophyte is a deep-rooted plant. By some scientists' definitions, phreatophytes draw water from the water table and not that soil zone above it known as the vadose zone. But some other scientists are not so persnickety, and so they didn't mind us just referring generally to these kinds of plants as phreatophytes. The kinds of plants we were talking about are, we really were focused in our discussions and our literature review on woody shrubs, and that would be mesquites, particularly, and juniper also, but that would also include tamarisk. And of course, I don't think it qualifies as a woody shrub because it's more like bamboo, but arundo is another phreatophyte that came up in discussions. It's important to note that we're talking about encroaching plants, plants that are invading, they're hardy and persistent, they're expanding their range. And this means that they're plants, they're winning in the competition for the space, the place. And it means that they're difficult to eradicate. It's also important to note that just because it's a phreatophyte, it does not follow that it's using more water than the vegetation it replaced. And I think that's kind of like the the converse of what Bruce was showing, that taking away vegetation doesn't necessarily lead to conditions that cause more snow melt to get into rivers. Taking away woody shrubs doesn't necessarily lead to conditions that result in more water reaching a river or the water table. And one other important note about phreatophytes, and that is that there's a reason why people on the land are observing encroachment. We don't necessarily know why the encroachment is occurring. Could be many things. It could have to do with human land management policies or decisions, and it could also have to do with changes in the climatic conditions that give the upper hand or upper branch, if you will, to these woody shrubs. So there are many, many variables. But think of these, next slide, please, these plants as making their move right now. I just thought it would be interesting to note that encroachment of these kinds of woody plants is being observed throughout the western half of the United States. You can see that it's much higher in the central Great Plains. The average, I found a study cited here that calculated that the average encroachment of these woody plants is 0.85% per year. So that's pretty significant. Next slide. So with all that background, oh, that's really visible. That's easy to read. I think my my slide transparency is not in effect in the transition. So I'll just, so with all that background, I'll read the question. Can phreatophyte management increase water supply? And probably not surprising to those of us who have been listening to the last presentations, it's not easy to answer this question. It's complex and highly localized, and it's very hard to generalize about the impacts of phreatophyte management. Some of the critical variables include the evapotranspiration rates of replacement vegetation, the soil erosion and sedimentation that may result from removing the phreatophytes or woody plants. And then the biggest factor is probably ongoing maintenance. As I mentioned before, these are the plants, they're the survivors and the winners, and they're persistent, and getting rid of them and keeping them out is very difficult. Next slide. Long-term increases in water yield are likely to result only when a relatively high leaf area species is permanently replaced with a lower leaf area species. And there aren't many opportunities for this kind of management strategy, but that doesn't mean that there aren't any opportunities. Next slide. So all of the experts that we interviewed concurred that there are possibilities for improving essentially not so much water supply, although water supply is inherent in this, but improving soil health and watershed function through phreatophyte management. Some examples are that in areas of heavy shrubby mesquite encroachment, removing that mesquite can improve. There's some research by Pam Nagler, that removing them can improve springs and soil moisture and improve the functionality of a watershed in general. There is some indication that in upland areas with higher precipitation, greater than 18 inches per year, the hydrological response to removing woody shrubs is more significant than in areas that receive less precipitation. And then there are zones between riparian areas and grasslands where there is encroachment, and there is some indication in research that removing mesquite in those zones can improve habitat values and improve the watershed functionality and have an impact on water supply. An example of an area where there's research showing that removal of woody encroaching plants is not helpful is in a place like Wilcox Playa. You can take out that vegetation and the water that is saved by removing that little engine of evapotranspiration is simply evaporated from the soil. Next slide. So we have some conclusions. Our recommendation would be that at a future meeting, we have some of the scientists that we've interviewed answer more specific questions about opportunities for research. I think the SRP, what Bruce just presented on the kind of research that SRP is doing now on stream flows and fry is a good analogy of the kind of research that needs to be done in this area. We want to figure out where are there pilot projects that are the right sites for this kind of research. And there was a real emphasis among the experts that we spoke with, and I thought this was really important. The research to date often looks at just one variable, and often research conclusions contradict each other. And there's a kind of a sense that there's a need to get a multidisciplinary team together to have to really answer the questions that come up in the research and do it over a long-term project, probably a minimum of 5 years, using the kind of cutting-edge tools that Bruce highlighted, LIDAR, INSAR, GIS, using modeling and monitoring of outcomes, and including land use variables so that we can really look realistically at the ongoing beating back of the encroaching phreatophytes. I just learned this morning that Senator Sinema has introduced legislation to fund the removal of non-native plants for water benefits for certain, it will be grant funding projects that qualify for watershed or water benefits. The kind of pilot projects that I'm proposing here are the kinds of projects that would be the supporting case for more significant funding in the future for ongoing management. That's really all I have. I do invite, I welcome Holly, Chuck, and Ruth if you have any additional comments.
Thank you very much, Sarah. Let's go into comments on all
I think what we heard there was that we're going to go into comments and questions for all presentations, but we'll start with Chuck's presentation. We did have quite a few questions for Chuck. Starting first off is from Jennifer Martin. The WI pilot program showed an increase in a given storm, but does statistical significance of the increase hold up in the context of precipitation over the course of the entire season? You're unmuted, Chuck.
Thank you. The Wyoming experiment suggested that for individual storms that meet the seeding criteria, there was a statistically significant increase in precipitation in the target zones. As I mentioned previously, when you compare year-over-year trends, you need to understand whether a particular year had sufficient storms of had the appropriate criteria to seed. So if you have few seedable storms, then it's unlikely that you're going to generate a large increase in a, for lack of a better term, a dry year. The most of the science suggests that in years where you're near normal, or slightly above normal is when cloud seeding generates the most benefit year over year. So you capture about 80% of the year-to-year variation. Lower 10% of years or the upper 10% of years, you see much benefit.
Okay. We'll move on to Brad Strader, who says, are we playing God by not allowing Mother Nature to choose when, where, if she's going to dump snow? How many acre feet do we get in return for the 2 to 3 kilograms of silver iodide? How much does a 2 to 3 kilogram silver iodide application cost in return for the acre foot yield?
So I'll set aside any ecclesiastical projections about what we should or shouldn't do. I would note that we impact and manage our environment in a number of ways, as Sarah's presentation and the forest thinning presentation line as well. Setting aside that, the estimated cost for on a per acre foot basis is generally in the range of between $50 and $100 an acre foot to generate the all-in cost for monitoring operation. The range is based on 5 to 15% snowpack translated into runoff. I can't really convert 5 to 10 pounds of silver iodide into dollars per acre foot. But when the water managers in Wyoming operators did their analysis, they estimated between foot.
She looks like a 46-year-old.
Sorry about that. Folks, just to make sure that if you're not speaking, please mute yourselves. Thank you. Moving on to the next question. Kathy Ferris is asking for a rather simple answer. Is cloud seeding proving to be an effective way to increase water supplies?
It read of the current state of the science and the operations that we've observed and participated in. The answer is yes. As I indicated previously, depending on the year, depending on the storm, the increased runoff is estimated to cost between $50 and $100 an acre. The challenge in Arizona is that we will face warmer storms and would likely, silver iodide may not be the most effective aerosol, but certainly the 92 experiment indicated that it had promise in the right location.
Got it. Thank you. And lastly, from Jake Linderking for Chuck, are there any entities claiming that cloud seeding is taking a downstream or downwind area's precipitation and or water supplies in the U.S. or other areas in the world this may be occurring?
So there in the early 70s, Nebraska was threatening a lawsuit against Colorado for cloud seeding, but they never went forward, and so there hasn't been that type of litigation in the Western U.S., and programs have been operating for more than 50 years. as I indicated, California, Idaho, Wyoming, Utah, and Colorado. They are regulated by the state. In fact, Arizona has a cloud seeding snowpack augmentation statute that is regulated by the Arizona Department of Water Resources. You can apply for a cloud seeding permit by this from the state of Arizona. Zach, you look nervous about that. Teasing.
No, I'm not nervous. Just trying to manage the chat box here. Cool. So is that all, Chuck? That's all the questions that we had for you here.
Internationally, there hasn't been any activity with regards to downstream impacts, and the technology has been applied in a number of places in Asia, in the Middle East, for rainfall programs.
Got it. Thank you, sir. Moving on to, there are a few questions and comments made in the chat box, and there were replies given by the presenters. I'm just going to read those real quick. So Gary Beverly had mentioned that the BOR analyzed the potential costs and benefits of the 4FRI forest management on the Verde watershed, and he was asking if we were aware of the study. Basically, they found that treating 160,000 acres would yield about 3,000 acre-feet per year. But thinning pretreatment is required at 7-year intervals. Cost was estimated at about 2,000 per acre-foot. Lots of assumptions involved here. The above data is in the CYHWRMS study, Central Yavapai Highlands Water Resource Management Study. And Marcos had replied that he's familiar with that, and there's a TNC hydrologist at the time that had contributed to it. And the study that Marcos described worked on an improved forest water model, what was featured in that report. So improved in terms of understanding forest thinning effects, improved in understanding climate effects. A comment from John Munderloh. He says that these studies should examine several other essential issues for Arizona, including woodland restoration, about 10 times larger than forests, increases in groundwater recharge, not just surface water runoff, and soil restoration. And Bruce had noted that to John that in SRP's analysis will include recharge, but is currently focused on the ponderosa pine forests. And I'm sure I'm always messing this name up. Is it Tice or Tice? I think it might be Tice. Tice Suppley. New modeling about woody encroachment and effects to groundwater recharge concludes in some situations woody encroachment can benefit groundwater recharge. As always, knowledge of the site should inform management. And then she has a link there to some articles. She says that, so Sarah Porter says that they had consulted two of the authors of that report, Osvaldo Sala and Enrique Vivoni. In answer to Warren's question there in regards to the presentations, which is a great segue to what I'm supposed to copy and paste into that chat box. I'm going to post this here. So there is a link to the GWAICC webpage. All of the committees are featured on the GWAICC webpage. All materials, meeting materials, presentations, and recordings of the meeting will be in each of the committee's tabs. So just click on a tab for the Long-Term Water Augmentation Committee, and we'll have documents as well as these presentations here. And you'll find a recording within the next few days. All right, Wade, anything else for the committee here?
Did we lose Wade?
He's unmuted. Wade, can you hear us?
If I may, I'm certainly not a Wade Noble. This is Cindy Rule, but we have about 10 minutes left of our meeting time. And is there any other discussion or questions for the presenters about these augmentation possibilities or potential augmentation options? It looks like maybe Wade is back with us.
Can you hear me now?
Yes, please take over.
Okay. I think we're probably going to have to come up with some recommendations that the committee can consider so that we can evaluate them and then go forward to the council with those recommendations. I suggest that the committee schedule another meeting, probably in 90 days, more or less. And at that time, we will have prepared some ideas as to what we can say to the council and therefore to communities and others in Arizona. Here's what you can do about cloud seeding or phreatophyte management or forest management that will result in water for you. Each of these concepts does not lend itself to a community going out and saying, gosh, I'm going to start a cloud seeding program because I know I'll get this much water out of it. It looks to me, and I'm going to exercise the prerogative of the chair, that these have to be more broadly based programs that we participate in to increase the overall amount of water available to, generally speaking, Arizona. What do others think about that?
Looks like we have agreement. Chuck, Warren, Sarah, Jake, and Pam. Carol says that we have a number of questions for discussion that will help. Virginia and Jamie also say that they agree.
Then why don't we get with Chuck, Marcos, and Bruce, and Sarah and devise some, shall we say, subcommittees to work up outlines of recommendations so that we can then have a committee meeting and Zach and Cindy can start looking at about 90 days down the road for a committee meeting date.
Got it.
One of the things about these online meetings is you can't see everybody nod their heads. So we're just taking it that everybody is nodding their head.
Well, if I can jump in, this is Carol.
Good.
Okay, thank you, Wade. So we set up a few questions for discussion, and we were hoping that the committee would have some time today to even begin discussing these augmentation strategies just generally, whether we should start to think about them as, you know, whether these are even a viable consideration based on what we've heard today. So are you thinking we need to break out into additional subcommittees to begin exploring these further? I'm just trying to follow a little better what the strategy is.
Well, in 10 minutes, we're not going to get anything done.
So
I think that by itself says we're going to have some further work done on this. I agree with you. The best way to have further work done on this is to break it up into smaller committees and to have them start working on whether or not the strategy itself is going to provide some water. And you have to in turn decide who can participate in it that can get some water out of it. So we're probably going to be looking at those who have provided the expertise today to help us a little bit in organizing that by taking on some subcommittee efforts.
okay, we've just sort of exponentially ramped up. We've just created then 3 more subcommittees. Just I'm trying to be considerate of everybody's very busy schedules here. I'm just.
I think what we'll do is get offline with Chuck and Bruce and Sarah and see if they would be willing to take on drafting some ideas as to what we could do with these strategies. And then having a committee meeting, discuss them and refine them for the purpose of presenting them to the council.
So you're talking about having a working meeting, Wade, is that right?
The next one, 90 days down the road.
Why don't maybe we can maybe we can just have a small, that I kind of like where you're going with that, Sarah. Maybe just a small group of us can get together and discuss next steps.
And I liked Wade's idea of kind of refining the questions for the larger committee to discuss. So I was envisioning that we could do some more concentrated discussion and thinking about these questions that are up on the slide now to help move the discussion along, so that at our next meeting we can end with conclusions to recommend to the big council.
Okay, all right.
And I'd like to go a little bit further, and that is when we get together next time for a general discussion at the committee level, we need to go beyond just does it look like it's going to outweigh it, but have recommendations for how we can implement it so that the council can provide information to those who are interested in how they can get into any of these strategies in a way that benefits them.
Let's take it one step at a time, if we could, and have that first meeting and talk about what we think is reasonable. I don't want to. Everybody's got a lot going on right now, and we have a lot of really big things in front of us. So I just want to be realistic about what we can potentially achieve. So let's start with that one meeting and try to work from there.
As long, Carol, as we can have 3 separate subcommittee meetings or sub-meetings before the next general meeting, so that something can be drafted so that we can present it to the committee for discussion. But another committee meeting like this where we just talk about it generally is not going to be very helpful.
We have a couple of comments in regards to this proposal. So Bruce Hallen doesn't think it'll take much time to answer these questions and respond to these questions. He says that since there was another group that had prepared issue papers, maybe that has a plan for each of the 3 folks who presented today, just small groups. Agree with Wade, have a non-formal, this is from Warren Tenney, have a non-formal offline meeting to work to develop next steps and possible recommendations for the committee to discuss. MU says, I like the idea of a summary, maybe a couple of pages on each idea with some recommendations for the long-term water augmentation committee to discuss. Stephanie Smallhouse says that She would like a bit of time to look through the studies for the phreatophyte papers prior to further discussions. Chuck says that he's happy to participate in a small group effort to refine and outline a proposal for consideration by the committee regarding weather mod and snowpack augmentation. From Kathy Ferris, she just wants to note that we need to be respectful of ADWR's staffing limitations and open meeting laws. Leslie also notes that a one-pager on each of the topics with next steps.
Excellent comments. We'll follow up on them. Post-meeting here, we'll get together with ADWR and with the three principals and Marcos who presented today, and we'll start working through to get something put together in time for a later meeting, 90 days or more or less down the road.
All right, sounds like a plan.
Thank you so much, everybody, for attending today, and especially Cindy and Zach for making this happen. Our presenters did great. We really appreciate you.
Thank you, Mr. Chairman.
Thanks, Wade.
Thanks for attending, everybody. Take care.